these get a little bit more advanced, no doubt. We can do compositions with these inverses, and that's what the book likes to practice with. So let's go to number 6. Cheat sheet here. Composition of two functions. Let's say the cosine of the tangent inverse of the square root of 3. Now, as intimidating as these problems appear on the surface, they're really not super terrible. Because you treat composition of trig functions the same way you treated composition before. Again, this is not cosine times, this is cosine of. Similar to when we would write this. This doesn't mean the f function times the g function. This is a composition of two functions, f of g of x. Well, tangent inverse of the square root of 3 is serving as our innermost function. And if you remember when you evaluated compositions, you always started with the innermost function and you worked your way outside. So that's exactly what we're going to do in this problem. Job 1. What is the tan inverse of the square root of 3? Like I said, the sooner we get these memorized, the easier these problems go. The tan inverse of the square root of 3 is basically saying tangent of x equals the square root of 3. Yes, we are in Q1. That is positive. Square root of 3 is positive. So I would say that tangent inverse of the square root of 3 is either 60 degrees, or you can put in pi thirds, whichever, but you make it whatever you're comfortable with, because the next job is you now have to take the cosine of that answer. The cosine of 60 degrees, we know, draw a 60-degree angle. Maybe it would have been better just to have this thing memorized as well. This is 1, this is 2, this is square root of 3. What's the cosine of 60? The answer is 1/2. So the cosine of the tangent inverse of the square root of 3, the final answer is just 1/2. And this is how you handle all of the compositions. They look terrible, that you're composing two functions, or even 3 functions, or 4 functions, that, just look really bad with these regular trig functions and their inverse. But understand, you're just going to work from the innermost outward and evaluate. Okay, so number 7. Let's try a sine of a cosine inverse. Let's throw in negative square root of 3 over 2. Really should have parentheses around that. All right, again, the idea is you're doing a composition sine of the cosine inverse of negative square root of 3 over 2. So job 1 is you got to calculate this, and cosine inverse, remember, its output is only in quadrant 1 if it's positive, not this time, or quadrant 2 if it's negative. So this has to produce a quadrant 2 answer. So when I think about this, cosine inverse, forget the negative for a second. What's cosine inverse of the square root of 3 over 2? Well, that is 30 degrees, but keep in mind that's merely the reference. That's your reference angle in Q2. Seems like we're going through a lot of formalities, but we got to be so careful when we do these. So 30-degree reference in quadrant 2, quick picture, would mean we're talking 150 degrees. So the idea is we're taking the sine of 150 degrees. Cosine inverse of square root of 3 over 2 is 30. Cosine inverse of negative square root of 3 over 2 has a 30 reference angle in quadrant 2. So we have to go with 150. Meaning this problem simplifies down to the sine of 150. Now we already have the picture drawn. Sine of 150. Well, 150 has a reference of 30 in quadrant 2. How it works in quadrant 2, we got 1, we got 2. That will actually be negative square root of 3, but that's not going to matter one bit because sine of 150, we're going to go with opposite over hypotenuse. Also 1/2 sine is positive in quadrant 2. The idea stays the same. It's just a matter of, how many functions we wish to compose here. Let's try a little bit different. Call this number 8, I guess, is what it is. Cotangent of the cosine inverse of 1/2. All right. Now you notice the cotangent snuck in there. And your question might be, okay, what about the inverse cotangent? What about the inverse cosecant? Those can be handled pretty simply from our known big three, the sine inverse, cosine inverse, tangent inverse. These have to behave somewhat similarly. But the idea is we're just dealing with cotangent, not cotangent inverse. All right, so this particular problem, say the cosine inverse of 1/2. Again, we'll be talking quadrant 1, so this one isn't too bad. We don't have to worry about a reference angle. Cosine inverse of 1/2 should be 60 degrees. Or you can go with pi thirds, but in this case, we're just starting off the composition, so pick what you feel comfortable writing. My guess is right now we're still comfortable with degrees, which is fine. Now we have to calculate the cotangent of 60 degrees. That would be a terrible idea. Draw a picture. 60. We got 1, we got 2, we got the square root of 3. And realize cotangent is not one of our big three, so we think it's the reciprocal of tangent. Tangent would be opposite over adjacent. That would be the square root of 3 over 1. Cotangent has to be the reciprocal, 1 over the square root of 3, which is square root of 3 over 3. Now, as far as how this problem would change, keep everything the same except for the cosine inverse. Let's make it negative 1/2. And things do change because this we now have to evaluate in quadrant 2. And as I was saying, ignore the negative, and that gives you a pretty strong clue as to how we're going to have to figure this out. Now, when you ignore the negative, we find out it's 60 degrees. So I'm going to say 60, but again, that's a reference. That's going to be our reference angle in Q2. So the cosine inverse of 1/2, that's 60. The cosine inverse of negative 1/2 has a 60-degree reference in quadrant 2, which makes it 120 degrees. That's a 60-degree reference. So this comes down to really the cotangent of this time 120 degrees. What's the cotangent of 120? Well, it's the same thing, we could say, as the cotangent of 60 degrees, but you're in quadrant 2, where cotangent is negative. Remember doing things like this. Deal with the reference angle instead of the actual angle. So, negative cotangent of 60, well, don't have to reinvent the wheel here. The cotangent of 60 is the square root of 3 over 3. And then we just take the opposite. Okay, well, a couple special ones just to kind of solidify this point. Go with number 10. Not too far there, I could be in trouble. Let's see what we got. Let's find the sine inverse of the cosine of the sine inverse of the square root of 3 over 2. Again, these problems look absolutely brutal. They do. I mean, you're doing a composition, a threefold composition. F of G.
Teachers, just a quick announcement.
Yeah.
If you're wearing red today, they're going to take a quick picture. If you're willing to be in the photo, down in the commons area at 12:30. Once again, if you're wearing red and you're willing to be in the picture, 12:30 in the commons. Thanks. Have a good day.
No and no. Sine inverse of the square root of 3 over 2 will be task number 1. So we'll say this is sine inverse of the cosine. And again, we're talking quadrant 1. We've got to go through this painful detail. Sine inverse of the square root of 3 over 2, that is going to be 60 degrees. You can see it keeps coming back to the same few angles over and over. There's only so many ratios we have that produce 30, 60, and 45. Okay, the cosine of 60, right, doing the math, cosine of 60 is just going to be a half. So now we have the sine inverse of 1/2. The next step of the composition. Then sine inverse of a half. Again, this will be Q1, no problems there. And we'd say sine inverse of a half would be 30 degrees, I suppose we could say, or I guess pi 6 if they requested radians. So whatever they ask, or if they leave it up to you, well then it's your call. Degrees, radians, doesn't matter. So that's how a triple composition works. It should be no surprise here that you get values like this.